Let's discuss about solar constant. Solar constant is basically defined as, we can write about it, it is the solar energy received on Earth's surface per unit area per unit time. So it is measured in units of joule per second per meter square, or it is measured in watt per meter square. It is also sometimes called as solar intensity. If we just analyze the situation, we can state, say, if this is the sun, and say the radius of sun we can consider as Rs, and say its temperature is Ts. And if we treat sun as a perfectly black body, it is emitting solar energy in its surrounding. You can consider that it is emitting energy in complete three-dimensional space uniformly. And say from the sun at a distance d, say we are having our earth orbiting around the sun in the orbit of radius d. Now in this situation, the whole energy which sun is emitting will be distributed uniformly in the whole space. So a small fraction of the solar energy will fall on the earth's surface. If we calculate the total thermal power emitted by sun, which is of radius Rs and its temperature is Ts, we can easily calculate thermal power emitted by sun. This thermal power Ps can be simply written as sigma Ts to power 4 multiplied by 4 pi Rs square. The sigma A T to power 4, sigma Ts to power 4 will be the radiation power per unit area from the surface multiplied by the surface area of sun. Now as we can directly treat sun as black body, we have taken its emissivity to be 1. Now if we talk about this power which is distributed in the whole three-dimensional surrounding, what will be the amount of power per unit area received by the Earth's surface? We can consider that Earth is located on a very large sphere which is of radius d with sun at the center. So whole of its thermal energy emitted will fall on this spherical zone of radius d. So we can directly write power received per unit area on Earth will be, obviously this will be the power which will be normally received by the Earth's surface. This can be written as S because this is defined as solar constant, energy received per unit area per unit time. So energy per unit time will be the power per unit area. So this can be written as power emitted by sun divided by the total area on which the power is uniformly falling, which is 4 pi d square, as it is a spherical zone of radius d with sun at center. So this can be written as sigma Ts to power 4 multiplied by 4 pi Rs square divided by 4 pi d square. Here this 4 pi gets cancelled out. The value of solar constant we can write as sigma Ts to power 4 Rs square divided by d square. So I would advise you to keep this expression for solar constant on your tips, and there are many numerical applications which are based on solar constant also you'll encounter.